You've probably heard this story before. Somebody goes out for a walk or a jog or is just going about their regular day, and all of a sudden they collapse because their heart stopped. And if they don't have medical intervention, they pass away very quickly. So should you be concerned? Will your heart just stop? Well, let's find out. So what we're talking about today is called cardiac arrest, which is basically meaning the heart is stopping its functioning. You've probably seen those medical shows where they have like the heartbeat and then all of a sudden it flatlines. Well, this is essentially what's happening. It's showing the electrical activity of your heart just stopping, and that's the key. So in order to understand what's happening during cardiac arrest, which is an abnormality, we need to know how the heart functions normally. So let's get started. Your heart is composed of four main chambers, two on the top called the atria and two on the bottom called the ventricles. Blood will be coming into these atria and fill the atria. From there, the atria will contract and pump the blood downward into the ventricles. Once the blood's in the ventricles, they're going to contract as well, really strong, and this blood is going to go to two main circuits, either your body or your lungs. And you need this process to go on for your entire life, because when it goes to the body, it feeds the cells of your body, helping you stay alive, and when it goes to the lungs, it picks up oxygen, which you're breathing in, that your body needs to survive as well. So what does this have to do with cardiac arrest? Well, in order to contract the muscles themselves in the atria and the ventricles, we need to give them a signal, and that is through these cells called pacemaker cells, here and here. This top part is called the SA node. This is going to be your primary pacemaker of the heart. This guy is called your AV node. He's going to kind of be the secondary player in this case. So when your heart's about to beat, what happens is the SA node will fire signals all the way throughout the atria. So all of the atrial muscles will get excited at the same time because they got a signal from the SA node, and they'll contract together. So once they contract, the blood is pushed down. Well, now we've contracted the atria and the blood's in the ventricles. Now we need to tell them to contract, and that's the job of the AV node. The AV node receives the signal from the SA node and pauses for about 0.1 seconds before sending its signal to tell the ventricles to contract. Why are we waiting that 0.1 seconds? We want the atria to be able to fully contract before the ventricles contract. So it causes this sort of function like bum bum, bum bum, bum bum, and there's a 0.1 second pause between the atria and the ventricles contracting. That pause is incredibly important. So in order for your atria and ventricles to contract in that way, you need these pacemakers to be doing their jobs correctly. But sometimes they screw up. And this is when cardiac arrest potentially comes into play. When this signal from the SA node or the AV node just stops entirely, when all these signals stop, that's when the electrical conduction of the heart stops, and therefore you get that flat line. So the heart is not contracting the proper way. So what types of things cause this? Although we don't know for sure, we know that there are some factors that could contribute to it, primarily genetics and prior heart conditions. So things like congestive heart failure or atherosclerosis, the hardening of the vessels themselves, putting more work on the heart. But there also might be some sort of connection between fluid and electrolyte imbalances, which is really important when sending those signals, as well as hormonal changes that can directly affect the pacemakers themselves. And then maybe it's just random. Maybe these guys just short out randomly and it causes this cardiac arrest. That is a hypothesis too. So let's get back to our original question. Is your heart just going to stop? The answer is probably not. You see, your heart's an amazing organ. It has several backups just in case these signals don't get sent properly. You see, this SA node fires spontaneously every 1 to 1.5 seconds. This means we'll have a resting heart rate of anywhere from 60 to about 100 beats per minute. If you look inside the SA node, you have several little clusters, and these are clusters of cells. And there's a study that I'm going to link in the description below that talks about how sometimes different clusters of cells initiate this signal across the atria. So therefore, if one of them gets lazy, the other one can pick up the slack. And same thing, if this one gets lazy, maybe the others will pick up the slack. So there's a lot of pre-checks from those cells in the first place. But let's say they all suck. Get super lazy like it's a Friday at 4:59 p.m. before you clock out from work, right? If the SA node does not fire, however, we also have a backup to the backups, the AV node. You see, if the AV node doesn't get a signal within this range, it will actually spontaneously fire as well. This is called your escape rhythm. So regardless of if the SA node actually fires, the AV node will fire regardless and be like, y'all didn't do your job, so I'm going to fire my own, and we're going to contract the ventricles at least just to keep this thing pumping. So therefore, whatever blood was in the heart gets ejected and continues throughout circulation. And what's beautiful about this is that if this escape rhythm occurs, most of the time it will feed back to the SA node and be like, yeah, you didn't do your job the last time, so get started, buddy. So this is often what you feel when you feel what's called a heart palpitation, right? Like your heart skipped a beat and then it pauses for a second and then it restarts again, right? That's potentially the escape rhythm going, and then your heart feeds back to the SA node, it pauses, SA node fires, and we kickstart it again. So because of all of these backup checks your heart has, your heart likely will not stop. But what can you do to prevent it? Well, obviously, eat healthy, exercise regularly in moderation, walking, jogging, those types of things, and decrease your stress as best you can in this modern age. All of those things will help your heart stay ticking happily. Thanks for watching. If this was helpful, please watch the next video talking about the cardiovascular system in more depth.